All right, so we're just going to continue from where the last video left off, but this is the last kind of thing that we're going to talk about in terms of arithmetic sequences, and then we're just going to do a couple of follow-up questions, and then we'll do some geometric sequence stuff, and then if we have time in this video, we'll go into series. If not, I'll make another one. But where we left off with arithmetic sequences was essentially you could find the Tn, you could find a term, so T of 50 or T of 20, or you could find that term, and then you could also find what term a certain number was, or whether that term was part of the sequence. So the other kind of questions you're going to be asked to do are questions that ask you how many terms are in a sequence. And in order to figure that out, you're going to follow this two-step process. You're going to find Tn using the first three terms. So in our example, if we look at this 3, 5, and 7, we can determine that is, first of all, a first term of 3, and then a common difference of 2. And we can use that information to find Tn. So that's what this is saying. Write out Tn first. So we're going to go Tn, for our example, is 3 plus 2 times n minus 1. And if we reduce that, which I like to do because it makes it simpler when we use it later, we get 2n plus 1. So that's our Tn. And then what we do is, to figure out how many terms there are in the sequence, we simply take the last term, which is 129, and put it in for Tn, and we solve for n. So we say now 129 is 2n plus 1, which means that 128 is 2n. You subtract 1 from both sides, and then you divide by 2. And that's going to give you 64. And that's how many terms there are in that sequence. Okay? So that's another type of question. It's very similar in terms of what you have to do mathematically, because really all you're doing is the same kind of questions every time. You're finding Tn, and then you're either plugging in n or you're plugging in Tn to find how many terms there are, or what term something is, or what is the term that is, the 50th. So it's very similar calculations all the way through. All right? And then we'll just move into geometric sequences, and that's where I want to spend the most of my time on this type of sequence. So we talked about arithmetic sequences having a Tn term or an equation that you can write out, and geometric sequences have the same thing. So a geometric sequence is a sequence that has a common ratio. So if you think about the terms, if we just write them out, the first term is a, the second term is a times r, because there's a common ratio. The next one is ar squared, because we're multiplying by r each time, right? That's how we get the next term of the sequence. So we're going to times by r again, and that's going to give me ar cubed. And then if I times by r again, it gives me ar to the fourth, and so on. So you can notice a pattern. The pattern is the first term, and then the number of r's. There's a power now instead of 2d or 3d like there was in arithmetic sequences. Now it's r, or r squared, or r cubed. So the power is growing by 1. But it's 1 less than the term number, because we start with the first term, and the r power is r to the 0. And then the second term has r to the 1, if you can see what I mean. And the third term gives me r to the 2. So the pattern is that you have the first term multiplied by r to a power of n minus 1, where n's the term number. Okay? So that's where this comes from. It's not just something we made up, but it's just, that's the pattern of the terms. And all we're going to do with geometric sequences is, first of all, you have to be able to recognize when do we have a geometric sequence, and then we have to be able to do the same calculations that we did with arithmetic sequences. So if you look at examples, here's an example of a sequence, and it says, tell me what A is. So very similar to arithmetic sequences. A is the first term. Tell me what the ratio is. To find the ratio, we're dividing, right? So we're going 2 divided by 1, 4 divided by 2, 8 divided by 4, and you'll notice that those all are 2. So the common ratio is 2. We're just doubling everything. And you may be able to recognize that without actually dividing the terms, but if you can't, that's how you find them. And then Tn, we just plug in A, which is 1, and we plug in R, which is 2, to the n minus 1. And if you then simplify that slightly, you don't need the 1, so you have 2 to the n minus 1. That's how you find the first term. Okay? So you recognize the geometric sequences at a geometric sequence, sorry, by dividing successive terms and showing that the ratio is the same. And then once you have that, then you have your term, your Tn. And then again, I could do the exact same thing as before with arithmetic sequence. I can say, what's the fifth term then? Okay. Now you can, if it's the fifth term, you can just go 1, 2, 3, 4, 5. The fifth term is 16. But you can also go 2 to the 5 minus 1. And that gives you 2 to the 4, which is 16. So you can use Tn the same way as before. The other thing you're going to be asked to do is to find out, is this term part of the sequence? Right? So we'll look at a couple of examples of different types of questions, but it's very similar in terms of its approach to arithmetic. It's just that the equation is different. Okay? So the algebra comes out to be a little bit different. So here's another example. Find the first term, the common ratio, and the formula to find the general term for T20. And then it tells you two terms. So it's the same idea as before. We write out, we know T3 is AR to the 3 minus 1, so it's AR squared. Okay, and we know that's 36. And then we do T4 is AR to the 4 minus 1, and that means that AR cubed is 108. Okay, now you can solve this a couple of different ways. You can just notice that these are successive terms. In other words, R is the ratio between these, because I just multiply this by R to get that. So I could say, well, 108 divided by 36, that's going to be R, all right? And it's actually, that is going to be the case for whatever the difference is between these powers. Okay, so if this was R cubed, but that was R to the fifth, then we put R squared here is the difference in the ratio. Okay, but 108 divided by 36 is 3, so R becomes 3. And then once we know R is 3, then all we have to do is say, therefore, A times 3 squared has to be 36. So that means that A is 36 divided by 3 squared, which is 9. So you get 4 for A. So then we say Tn then is 4 onto 3 to the n minus 1. Okay, so we found the first term, we found the common ratio, we found the formula to find the general term, and now it says find T20. So the last thing to do is just to plug in 20. Okay, when you do that, you're going to get a really big number. Geometric sequences grow much quicker than arithmetic sequences. So I'm actually just going to leave this as 3 to the 19 because that's a huge number. All right. So it's a very hard thing to find bigger terms in a geometric sequence unless your calculator allows you to do something in scientific notation, basically. But it's not as easy. Arithmetic sequences, because they only grow by a common ratio, or a common difference, I mean, you can add 5 a bunch of times and still stay relatively small, but if you're multiplying by 5 a bunch of times, it gets big quickly. All right, but that's the example. And the same thing here, if you look at these, the R is different by 3. So in other words, T5 is AR to the 4th, and that's 48. And then T8 is AR to the 8th, sorry, is the 7th. That's 7. Okay, it's 1 less, is 384. So you notice they're different by 3. So we say R cubed then is 384 divided by 48. Okay, and then we have to figure out what that is. So 384 divided by 48. Let's see. I think it is 384 divided by 48 is 8. That's what I thought, but I didn't want to say for sure unless I knew. So then R is the cube root of 8. So R is the cube root of 8, meaning it's 2. Then we go back and say, okay, that means that A times 2 to the 4th is 48, which means that 16A is 48 because 2 to the 4th is 16. Then we divide by 16, so A becomes 3. Okay, when we divide both sides by 16. That means that Tn is then 3 on to 2 to the n minus 1. And then T20 is 3 times 2 to the 19, 20 minus 1, right? You want to write that up above. And again, I'm not going to evaluate 2 to the 19th power. So that's how you do geometric sequences in terms of those kind of questions. And really, that's all you have to be able to do with geometric sequences is find Tn, find a term, and figure out A and R from a series of numbers.